Hello, good evening. Can you hear me?
Good evening, sir.
You can hear me, right? Okay. All right. Can you see the screen? Hello.
Yes, sir.
Yes, sir.
Okay. All right. So here we are today. Okay. I can see how many people are here. How many? 8 to 10? Not more than that. Okay. Okay. So still the people are on leave or still enjoying chat. Uh, I don't know, but let us start with our business. Now, I think I have already posted one homework for you. Okay, you have already seen that one. That was on mean, mode, median homework, and another homework will be uh, put either today or tomorrow. Okay, uh, and gradually we have to proceed further, but still now we don't have any news about the confirmation about the stable server. Okay, so until and unless that comes, at least we are not going to hold the midterm exam in coming Wednesday. So until and so if anything, any change that comes, okay, after Wednesday, I'll put a notice for that. So keep and watch on Google Class or in your WhatsApp. So I'll ask Abhijit in that case just to post. Okay. Now, today we are moving from confidence level to another one, that is introduction, new chapter, that is introduction to the hypothesis testing. Okay. Now, so far what we have been doing in the last chapter, uh, we asked for that, we looked into that what value or interval of values that can be. Okay, just wait for a minute. Okay. Okay. So there, what we did is that what interval values can we use to estimate a population mean? Okay. There, what we did is basically from sample mean, we wanted to extrapolate population mean and all this thing. Now, whatever we did, now there is another question: is there any evidence or proof to suggest that the hypothesized mean is incorrect or not? We never thought in that line, basically. So that question comes up. Okay. So once we say that within this interval or values, okay, our population mean lies. So so far there was no such evidence or any proof. So basically, in a statistical analysis, uh, is that we use the data from a sample. Okay, that also we told in the last class, to make inferences about population from which this sample was drawn, because the sample is nothing but the representation of the whole population. So instead of doing the analysis of the bunch of data in the population, we are just picking out, let's say, 10, 20, or 100 data, and we are assuming that to be a sample and it is the true representations of population, and we want to have the inferences. Basically, that's what it is done. So it is the inferences that is done. So uh, what we just like here, you can say that the mean and the variance of the student in the entire country, that is the mean and variance of the gate score of all students of IIT KGP. Okay, so if we think about like that, you can also have same thing. Okay, like that. That's the way. Basically, we want to go that way. That so we have some sample, and from the sample, we wanted to have that it is for the whole country. Now, once we talk about hypothesis testing, now naturally some point that come to our mind, that what is a hypothesis, because most of the time we learned hypothesis either in mathematics, geometry, or in some chemistry. If you recall that there are some hypotheses in chemistry, and also in math some hypotheses. Okay, Pythagoras hypothesis. Okay, like that. So a hypothesis is an educated prediction. There are several, uh, several kinds of definition. So each and everyone has got their own way to define what is hypothesis. So if you look into the website study.com, you will see that it says that it is an educated prediction that can be tested. Basically, is that any hypothesis is such that it can be tested. Just like if you say that it is Pythagoras hypothesis, okay, or in algebra, if you have some hypothesis, you can prove. Sometimes it is given. If you recall, in our class 7, 8, or 9 level standard in mathematics, it was said, okay, you prove that, okay, fine, this side and this side, okay, that is greater than the third side or something like that, or some angles. So we knew that there are some hypotheses we have to prove that, and we used to keep it in our mind, and okay, memorize those things, and in the exam we used to. But at that time we never thought that what is what. Okay, so it is a, basically it can be tested. Similarly, another school that says that hypothesis is a proposed explanation for an phenomenon. That is as per Wikipedia, that anything that happens, okay, you can say that it is uh, mainly in biology or some other chemistry. We say that, okay, if that is some phenomenon is happening, so it is happening as per this hypothesis. Okay, just like in biology, you can say that, okay, there are some hypotheses of Mendel's Mendel's theory. Okay, so some people say that, okay, it is hypothesis that, okay, that heredity, that laws have to be that basically have to follow some rule and regulation. Just like if you recall that 9 is to 3 is to 3 is to 1. In biology, there are lots of hypotheses. Similarly, in chemistry also. And in Oxford Dictionary, it says a hypothesis is to define the relationship between two variables. So it is another way of presentation. And is another thought is like that: a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. So you see that each and every definition, okay, that has got its own way, but all of them are saying that, okay, fine, it has to be tested, or it is some relationship, or some evidence for further investigation, like that. Just like as I said, that in chemistry, it is Avogadro's hypothesis that volume of a gas is directly proportional to the number of molecules of a gas, and that is called, okay, and we know that one is, that is Avogadro's number. That is how much? That is 6.23 multiplied by 10 to the power 23. That Avogadro's number. So we know that 1 mole of any gas would occupy so many number, that would have so many number of molecules. Okay, so similar to that, we have a lot of hypotheses, and that can be proved. Okay, people, that means people have already, that scientists have already proved that. Okay, so uh, so nature of hypothesis testing is that it is formal process for making an inference. That means this testing process is nothing, but it is a formal process. Okay, as I said that earlier also, that any hypothesis can be tested and it can be verified. That's in the first definition. You can see that it can be tested. So uh, in hypothesis testing, the thing is that one has to make a formal process for making an inference, consider many of the concepts of a hypothesis test, and look at several decision making situation. Okay, so you have to look into different many of the concepts of the hypothesis test, and you have to see which is making the decision making. The entire process starts by identifying something of concern and then formulating two hypotheses about it. Now, once I say that formulating two hypotheses, uh, at at the very beginning, it may look okay. We were talking about at first only one hypothesis, then all of a sudden it is coming two hypotheses. Now, once we come into a more details, you'll see how it is. Okay, so until then, you cannot, gauge what is happening so far. Now, in statistics, basically, most of the question that comes is what is statistical hypothesis, and there are some terms like null hypothesis. Why is it important for a statistical test? Describe test in a steps in a test of test of null hypothesis. There are other steps that we will see. Instead of giving all these things, let's move further, then we can have idea. So there are some approaches. One is to that we have to conduct test on hypothesis. Okay, we hypothesis that one or more parameters have some specific value or relationship. Then we make decision about the parameters based on sample statistic. Accuracy of the decision is expressed as the probability that the decision is incorrect. Now, again, as I said, that we'll go little bit forward. Then all this, okay, in retrospect, it would look more meaningful. Otherwise, it will not look meaningful to you. Okay, so accuracy of the decision is expressed as the level of confidence we have in the interval. Now, again, we go into details that it is the statement that is something is true hypothesis. Statistical hypothesis test, a process by which a decision is made between two opposing hypotheses. See, I earlier said that there are two hypotheses have to be tested. Now, here we are saying that there are two hypotheses which are opposite in nature. And what is the reason that we took these two? The reason is that, that two opposing hypotheses are formulated such that hypothesis is negation of the other. Okay, one is just opposite of the other. If it says one is says yes, another says no. If you say it can happen, the other hypothesis says no, it cannot happen. Okay, then one of them has to be is always true. It's just like if you recall in geometry we used to have proof something like that, or in some other place. Okay, if this side is this, then but it can never be like that. So it what it is done is basically so two opposite in nature hypotheses are taken, and one of they are formulated in such a way that one of them is true. So if one of them is true, then the other is that is bound to be false. So that's the way it is done, testing. And then one hypothesis is tested in hopes that it can be shown to be a very improbable occurrence, thereby implying that the other hypothesis is likely truth. So as I said, that only the reason of taking these two is that just to make one of them as the true so that the other become false. Now, there are, okay, then we have been talking about statistical hypothesis. See, all these things will be only clear after we take some example and you work out some example. Only then it will be more clear. Until then, these are all in the form of just like a, a geometry proof. It's just like proof of the geometry in class 8, 9 standard or something like that. Okay. Or if you recall, some hypothesis or some proof of solid geometry. Okay, there we used to have this thing, that this kind of proof. Sometimes we used to only memorize them, but here it is not like that. Only thing, you have to be little bit logical to think. Okay, if the hypothesis is stated in terms of population parameter such as mean and variance, the hypothesis is called statistical hypothesis. So what is statistical hypothesis? That means if it is related to this population parameters, all these things, and data from a sample, which may be an experiment, are used to test the validity of the hypothesis. The reason is that we cannot think about the whole population, so we have to concentrate of a sample of an experiment, and we have to that check the validity of the hypothesis. A procedure that enables us to agree with the statistical hypothesis is called the test of hypothesis. So basically, for the test of hypothesis, you have to pick up a sample, and on sample you have to do anything that is related to population parameters such as mean and variance, and those and that hypothesis is statistical. So just like if we want to take the example, okay, now to determine whether the wages of men and women are equal, okay, because most of the time we know in any job or anywhere it is sometimes it is say it is some kind of discrimination that okay, even in USA also they said that this is not same. Okay, so for a long time there is a debate and all these things. Okay, similarly, another thing is a product in the market is of a standard quality. Now if somebody says no, it is not of a standard quality, so again you have to take the help of the statistics. You have to do analysis. Okay, fine, I have taken so many samples and then we tested this thing, like that. Similarly, whether a particular medicine is effective to cure a disease. Just like the recent days that there are lots of vaccines that are being discovered, or it's better to say not discovered, it is getting invented by several companies, but none of them have been successful, or somebody says it is. The other day, yesterday, I saw that one is biotech or something. Somebody is saying that medicine is 90% effective. Another one in France or somewhere in England that says 94%. So each and everyone has got their level of accuracy or whatever it is. So this is a good example which can be applied to. Okay, so whether a particular medicine is effective to cure a disease or not, that is another example. Now, there are two hypotheses. Okay, one is for involved in making a decision. In statistics, mainly people look into that basically two hypotheses, and one is called H0. And see, here it is, I have written HA, but mainly it is written most of the places in our book. You will see that it is H1. Sorry. Okay, it is H1. So first one, because of this zero, it is called the null hypothesis. That is just like a zero is termed as that is null hypothesis. So this hypothesis is to be tested, assumed to be true. Okay, usually statement that a population parameter has a specific value, that is the starting point for the investigation. Okay, and the alternative hypothesis is that is here it is HA, it is shown, but in most of the books you will see it is H1, or most of the reference it will. Maybe I'll set also in the in your exam or quiz or whatever it is, I'll set it as H1. So please be careful. So a statement about the same population parameter that is used in the null hypothesis. Generally, that is a statement that specifies the population has got a different value. As I said that if you recall just one or two slides back, we said that there will be two opposing two hypotheses. One is negation of the other. So whatever the specific value here, this null hypothesis has got. Okay, there will be that alternative hypothesis will have the population parameter that has got a value different. So in some way from the value given in the null hypothesis. So one has to be negation of the other so that it is not the same. The rejection of the null hypothesis will imply that likely truth of this alternative. So if we can prove that, okay, fine, this null hypothesis, okay, that doesn't work, that means this one is work. So that is going to imply the truth of this alternative hypothesis. So that's the way it is basically it is proved. So now it will be, if you go back, it will be more clearer. So as I said here, that the two opposing hypotheses are formulated so that each of the hypotheses is negation of the other. The way one of them is true and the other is always false. So now it is that null hypothesis and alternative hypothesis, they will have the value different from each other. So they are not going to be the same. So if one of them is not true, that means the other is okay. That is okay. That is valid, basically. So the main purpose of this statistical hypothesis testing is to choose between two competing hypotheses. So these are two competing. Okay. One hypothesis might claim that the wage of men and women are equal, while the alternative might claim that men make more than women. So see here it is says, okay, fine, if their wage is W1 and one, another is W2, okay, so that is okay. In another case it is says W1 is greater than W2. Okay. So if I say that W1 is the wage of men, okay, so hypothesis test start by making a set of two statements about the parameters in question. Now, the hypothesis actually to be tested is given the symbol H0, that is a null hypothesis. Earlier we talked, and the other hypothesis, which is assumed to be true when null hypothesis is false, is referred as alternate hypothesis and also symbolized as H1. I said that some places it is termed as H1. So these two are just opposite. So if you can prove one of them is correct, if you can prove W1 is equal to W2, that means this would be wrong. Or if you can say that, okay, whatever you got, it is not right, then the either it will be okay, or maybe that W2 is greater than W1. Okay. So I do not know which one is correct and what preference is given. So basically the general goal of a hypothesis test is to rule out chance or sampling error as a plausible explanation for the results from a research study. Hypothesis testing is a technique to help determine whether a specific treatment has an effect on the individual in population. Okay, so it tells us that whether a specific treatment, okay, has an effect. What does this mean, specific treatment? That we'll see also later. So suppose you are investigating the effect of a new pain reliever. Let's take just like in our nowadays we use either Move or Volini or something like that. That is basically for pain reliever of the muscle pain. Okay. Now, if somebody has already uh, one company has invented one new pain reliever. Now, you hope that the new drug reliever relieves the minor muscle aches and pains longer than the leading pain reliever. So, if somebody says that, okay, Volini is not that much, and this new invented, okay, that cream is its leading pain reliever, let state that null and the alternative hypothesis. So, what is the solution? The new pain reliever is no better than the leading pain reliever. That is one way. Okay, that is H0. And if H0 is wrong, then if I say just the opposite, just like H1, HA or H1, that new pain reliever lasts longer than leading pain reliever. So one is that, okay, here the pain reliever, this new one, the invented one is not good. Okay, so than the existing one. Okay, and in another one, it has been found that here the invented one that lasts longer. That means its effect is more than the leading pain reliever. That means it is more effective than the leading the existing pain reliever. So if one of them is okay, if one of them is correct, okay, if this is right, that means this is wrong. Okay, similarly, if this is wrong, that means this is correct. So these two are just one is the null and this is the alternative hypothesis. So you have to formulate in such a way that it is no better than this. In another case, you have to say, okay, fine, this new reliever that lasts long. Okay. So that's the way you have to formulate the hypothesis testing. Now, the hypothesis test is used to evaluate results from a research study in which a sample is collected from the population. Okay, so as I said earlier, also that basically hypothesis testing you have to do it on a sample which you pick up from a big population. Basically, whatever you do, you always do the experiment or anything that is with the sample, not with the whole bunch of data of population. And the treatment is administered on the sample. Whatever you do, whatever you want to do, anything, that treatment, that is your statistical treatment. Okay. And after this treatment, the individual in the samples are measured. Now, what kind of treatment? Let's say, okay, uh, if you just pick up or subdivide into 3 or 4 different groups, okay, and you want to have some kind of testing. Let's say we have the drug, okay, newly invented drug. Then we say, okay, fine, we have 100 number of drugs, and okay, let's divide into 5, 20, 20, 20. Now we put this 20 in the eastern zone, we put 20 in the western zone, we put 20 in the northern zone, 20 in the southern zone of the country, and another 20 in the northeast. Okay, now we do this thing and we apply it, just like if I say for the COVID or any other. Then we have that, okay, this sample value, this sample that's mean or median or whatever it is, we already measure it. Okay, that the effectiveness was already made as measured. Then after administration, that means you use that drug over the people in that part of the country, northern, western, south, east, and the northeast. And then you see, and then if get the sample effect result. That's way, then you can say that how it is, or whether this okay, this hypothesis is that testing that you are doing, that basically you can say that I am doing some kind of hypothesis testing. Okay, now we have to say whether that is effective from the previous one or not. And in another case, you have this, just the one is null hypothesis and another is alternative hypothesis. Basically, that's the way you might have read in the newspaper very recently. I was reading that stage 3, it is not getting the approval from the ICMR or the some medical board or somewhere. Okay, so that means they have already uh, pre-decided what they would do in the stage 1, then stage 2, then stage 3, and they are collecting all this data and everything, so that they can put it in the form of table or wherever it is, that this is the proof that we have already gone through this test and we got this thing. So now let's say this hypothesis testing. So known population before treatment. Okay, and it was there that we know that okay, fine. This is the what is mu? Mu is nothing but the okay population mean, and the standard deviation is this 20. And you have done this treatment, and it is that unknown population after treatment, and there also we want to have, let's say we want to have the standard deviation 20, but we do not know what is the okay, what is the value of mu. Okay, so that's why it is said that known population, here it is unknown population. So that's the way this kind of testing are done. Now, if the individuals in the sample are noticeably different from the individuals in the original population, we have the evidence that the treatment has an effect. Okay, so basically, it's a only thing that you have to see that whether the result that you are getting is different from the original population, then only say that okay, fine, whatever treatment that we did, that treatment has got some effect. However, it is also possible that the difference between the sample and population is simply a sampling error. So there is always some error that comes, that is due to sampling error. So that is bound to happen. Now, decision making under uncertainty. You have to make decision even when you are unsure. School, marriage, therapy, jobs, whatever. Statistics provide an approach to decision making under uncertainty, sort of decision making by choosing the same way you would bet. Again, we'll come this thing next time. Okay. Uh, I do not want to go right now. Okay. Basically, why we are doing all these things, that will say this thing. Now, this hypothesis testing, the purpose of the hypothesis test is to decide between two explanations. The difference between the sample and the population can be explained by sampling error. As I was saying that you may not, it may not give the exact representation. That means only the thing is that you might have picked up from such sample where it does not give the true representation. Okay, so that's why there is bound to happen some difference, which is known as the sampling error. Okay, and if there is sampling error, then that does not appear to be a treatment effect. It is not due to treatment effect. The difference between the sample and the population is too large to be explained by sampling error. So if the difference between, let's say, whatever you have done, okay, the result from the sample and from the population, Okay, there is a wide difference. Even your sampling error cannot explain. Then you can be very sure that there is some effect of the treatment that you are going through. So just like let's say if you have this newly drug that is okay, that is administered, okay, it has been applied to uh, some patients, okay, first it has been applied to, let's say, 10 people, then that is the your sample, and if you put it for 100 or 1000 people, okay, or you see that the result is wide different. Maybe for your 10 people, okay, it is working very fine, but for 1000 people it is not working fine, and it does not come within the sampling error. So that means there is something wrong with the treatment effect, or the way you have used the injection. Let's say you have used the new drug, so it is due to that error, might have it has already caused this thing. So that's the reason that it may be difference between the sample and the population. So the difference between the sample and the population is too large to be explained by sampling error. There does appear to be a treatment effect. Maybe the way this drug is administered, there is something wrong, or you have taken it from, let's say, from wrong drug or something like that, or it was mixed with, let's say, some other contaminant that drug got. So it is a treatment effect. So once this kind of result come up, then all this medical, okay, mainly medical science and this biological science, they do lot of statistical analysis. uh, we are only thinking about the drugs because nowadays this COVID is happening. But other day I was talking to one person, and he used to he does some research in the area of carcinogenesis. You know what is carcinogenesis? Hello, anybody having any idea carcinogenesis?
No, sir.
Carcinogenesis is something, you would hear this term that carcinogen. Carcinogen means that which causes cancer. Okay, so for cancer treatment, this biochemistry people, they do lot of experiment. Okay, and they do analysis, and for their analysis, most of their experiment that run for more than 10 to 12 hours. In the early morning they start the experiment, and it is very tedious. I have seen in one lab. Okay, so uh, in carcinogenesis, they always look for this statistical data. They do lot of um, uh, this experiment, and those experimental results they analyze, and they tabulate it, put it. And in many places in USA also, this statistic is a part of this biological science. Okay, biological or this biochemistry. Uh, okay, so they always deal with this standard deviation, mean, these, that. Uh, I was talking to one person from NIH, National Institute of Health, and he was telling me this thing that they are very much, uh, I mean, they look into all this kind of data. Anyway, so that is part of hypothesis testing. Okay, just like the distribution of sample means if the hypothesis is true, all the possible outcomes. Sample means close to H0, high probability value if H0 is true. That means it is it follows this null hypothesis. Okay, and here we always say that okay, fine, that okay. we want to reject something that comes from this two tails. One is this tail, another is this tail, and this one is low probability values if H0 is true, extreme low probability values if H0 is true. Okay, so basically we want to keep the probability value here. If you recall, we are doing that area underneath that. If you recall, that was something like 0.95 or 0.9, something like that. So that means this zone is always lying with a very low probability value. Okay, these extreme two ends. Similarly, on this side also, uh, because the area was one, or the probability was one, and if you take off these two parts, that means you are just taking off this low probability areas. Okay, so, and this mu is obtained from your H0 null hypothesis if it is true. Now, whatever we talk about alpha level basically is nothing but this. In some places, it is called 6 sigma or sigma value, the critical region, and the test static. The following four steps outline the process of hypothesis testing and introduce some of the new terminology. Now, how we can do this hypothesis testing? Now, get the hypothesis and select an alpha level. The null hypothesis H0 always states that the treatment has no effect, no change, no difference. Okay, so according to null hypothesis, the population mean after treatment is same as it was before treatment. Okay, it would be the. Okay, the alpha level establishes a criteria or cutoff for making a decision about the null hypothesis. That means, if you recall that on each side we used to says alpha or sigma. Okay, that we used to say that, okay, that is 1 sigma, 2 sigma, 3 sigma. So instead of that, it is used this alpha level, a criteria of cutoff for making a decision about null hypothesis. The alpha level also determines the risk of type 1 error. We'll come to all these things. Okay, you recall this thing that this was 1.96, this was 2.58, and this was 3.30. If your alpha is equal to 0.5, that means, okay, if you say this is 0.95 or 0.96, then what it would be? And another is this, and another is this, then corresponding to this, all this thing, well, this is z value, and we're starting from z is equal to 0. Okay, now you have to locate the critical region. The critical region consists of outcomes that are very unlikely to occur if the null hypothesis is true. That is, critical region is defined by the sample means that are almost impossible to obtain if the treatment has no effect. Okay, so if the treatment has no effect, that means that it is impossible to obtain. Okay, almost impossible means that these samples have a probability that is less than the alpha level. Now we'll come back to this part again, so that it will be more clear to you. So I am not going further. Only thing you keep in mind for today's class, that what is hypothesis, and for hypothesis testing, we have to establish something. Now, establish means that we take two hypotheses. One is null hypothesis, another is that it is alternative hypothesis. In null hypothesis, that one is the negation of the other. So whatever we assume in one null hypothesis, in the alternative hypothesis is just opposite. So we have to prove one of them. If one of them is true, that means the other is the wrong. So that's the way we have to proceed. Basically, we want to say that uh, whatever that is, we just want to verify basically whether it is true or not. Now we will again go into more details and we will further elaborate because uh, there are some points which it may not be clear. So I'll also post some reference which for your reading, that so that they will be easy for you to understand better. It will be able to follow them. So only you remember this. There are two hypotheses, and that's all. Again, in the next class, we'll explain further. Okay. But all of them are just they are just getting concentrated with only either from the sample to population okay data, and basically in the normal all this normal distribution data with the normal distribution, how much you are removing this critical zone or critical region. Okay, so how you can determine those critical region? That's the, I mean, basic vital things that you have to keep in mind. Okay, so until then, we'll not proceed further. But before that, let me take your attendance. Okay, for which you have so much. So let me ask one by one. If you are there, you say yes. If you are not, hello. Yes.
Yes,
Obhinav,
yes, yes.
Naveen Sinha. Okay. Abhishek Kumar, Avinash Kumar, Ashish Kumar Gupta, Avinash Raj, Amitesh Raj, Dhananjay Kumar Singh, Harshit Agarwal, Sai Krishna, Keshav Gupta, Pawan Kumar Kiladi,
Yes.
Kundan. You are there, Pawan Kumar?
Sir.
Hello, Pawan Kumar.
Yes. Yes,
You are there.
sir.
Okay. Kundan Kumar. Kunal Kumar. Bhargav Mal. Manish Singh. Mobin Akhtar.
Yes, sir. Present, sir.
Okay. Mobin Akhtar is there. Manish Singh is not there. Nafis, Kashmi Nafis, not there. Nand, huh?
Present, sir.
Okay, Nafis, Kashmi is there. Nand Kumar Singh,
Present, sir.
pardon? Your
Hello.
name, please. Your
Present,
name.
sir.
Your name.
Sir, Nand Kumar.
You are Nand
Sir,
Kumar.
Nand Kumar.
Yeah.
Yes, sir.
And Kashmi Nafis. Nafis Kashmi. He is not there. Nafis Kashmi. Okay. Nikhil Suneja. Deepak Palli.
Yes, sir.
Prem Prakash Singh. Puneet Karsal.
Yes, sir.
Rajinikanth.
Yes, sir.
Ravi Shankar Kumar. Sajid Kumar.
Yes, sir.
Okay. Satyendra Datre,
Yes, sir.
Siddharth Vikram, Sunil Gupta,
Yes, sir.
Suraj Kumar, Utkarsh Singh.
Yes, sir.
Yes, sir.
There are two yes, sir. Who is for what?
Sir Kunal Kumar.
I
Sir,
did not
Utkarsh.
ask Kunal Kumar.
Yes, sir.
I asked first Kunal Kumar. You did not that time respond, or you are not there. I asked Suraj Kumar. Suraj Kumar. Utkarsh Singh,
Yes, sir.
Veer Pratap Singh, Meena. Meena is not there. Okay, Josh Khandelwal, Kunal Kumar, Kunal
Yes, sir.
Kumar.
Yes, sir.
Yeah. Last time you were not there. I mean, when I called just 2-3 minutes back, you suddenly popped out from nowhere. Anyway, okay, all right, I got it. Meena is not there, na? Meena Mangani. I saw her name here.
I haven't got my name, Bhargav Male.
All on a sudden, if you come up, then it's very difficult.
Sir,
You
I
know?
came from the office outside and I am responding for this.
Well, the class is not for that. Next time it will be total bass. Once it is called, you are not there. That means I would assume that you are somewhere else. Okay,
I came
you are
from
not
the
there.
office.
No, it's not that. It's not the whole purpose. Is not to make it on. Okay, you have put your video on. That doesn't mean that you are here physically. Okay, all right. Bye.
Sir, my name is also not there. Ashish.
Well, as I said, I called several times. Nobody was there. Just okay.
I
It
went
cannot
to
be like this thing.
my
No.
networks
That's
was
the reason
problematic, sir.
know. No. Once you hear from somebody and get some message and you pop up from somewhere, okay, it's not like that. Okay. Once I called it, that's means you have to be there. It's not the whole class is just from the only at the beginning or at the end. All right. See you next class.